Okay, this video is about solutions, concentration, and dilution. Okay, so a solution is when we have a homogeneous mixture, two or more substances. Most of the times when we are talking about solutions, we're going to be talking about aqueous solutions. So that's where things are dissolved in water. So we can call them aqueous solutions, and they show up in chemical equations with an AQ symbol. So solute is the term that gets used for the substance that changes phase or is in smaller amount in the solution. So here's an image that represents the orange solute, and the blue particles represent the particles of solvent, which is usually for us water. And those particles are going to pull apart and break apart the solute if it's a solid and spread it evenly throughout the solution. So over on the right hand side is when we actually have a solution. Now, solutes can also be gaseous, and they can also be other liquids, but the idea is that they will get evenly spread throughout the solution. And they get spread out down at the actual particle level. So in this image you can see the blue water molecules, and you can see a large crystal of sugar, and over time the sugar dissolves, and you have individual molecules of sugar that are now separated and surrounded by lots and lots of water solvent molecules. So now we have a solution of sugar. It would still taste sweet, but you wouldn't be able to see the sugar anymore because the particles have been physically separated down to the molecular and atomic level. Well, when we talk about reaction rate, we care a lot about concentration. Concentration has to do with how many solute particles are crowded into a given amount of volume in solution. So on the right here we have an image of one where there's lots of solute particles concentrated into the same amount of space, and on the left we have a diluted solution. So there's very few particles in that same volume. So few. And that relates to collision theory and reaction rates, because when we have many solute particles crammed into the same amount of space, they're going to bump into the other reactant particles more often. And so if they collide more frequently, then that will yield a faster rate of reaction. Okay, but what we're concerned with now is how do we take concentration values and how do we adjust them through the process that's called dilution. And so when we do dilution, we're adding more solvent, which pretty much for us is going to mean we're adding more water. And by adding more water, we're going to spread out the solute particles. There's going to be more water between every individual solute particle, and so they become less and less crowded, and so therefore there'll be fewer and fewer lower and lower frequency of collisions. Okay. So for us quantifying concentration, there's many ways to talk about how concentrated a solution is. Molarity is a very common one used in chemistry. For this video, we're just going to talk about percentages. We're going to keep it really simple. So if you thought about it this way, if you look at the solution on the left, there is 1 liter of solution in this beaker here. And you can see there are 13 yellow dots representing solute particles. So we could describe the concentration here as 13 dots per liter. Now over here, we've added another liter of water to that solution. So now the total volume is 2 liters, but it still has 13 dots. So now we have 13 dots per 2 liters. So if we divide that out, simplify it down, that means that there's 6.5 dots per 1 liter. So if you compare the two volumes, the volume on the right is 2 times as large. If you compare the two concentrations, the concentration on the right is half the concentration on the left. So if we increase the volume by adding more water, adding more solvent, as we did in this case, if we imagine taking the first solution and then we added water to turn it into this second solution, that is what dilution is. So we've added more water. Adding more water spreads out the solute particles, and that is what dilution is. And you can see that there's sort of a quantitative relationship there. When I doubled one, I halved the other. So one was multiplied by 2, the other was divided by 2, which is the same as multiplying by a half. Okay, so that brings us down here to the actual quantitative relationship of volume and concentration. It's what's known as an inverse relationship. So if you take the volume of the solution and when you add water, you double the volume of the solution, so that's 2 times the volume, then you're going to divide the concentration by 2. If you were to take this volume and triple it, then the concentration would be divided by 3. It would be 1/3 of the initial concentration, and so on. If we multiplied the volume by 10, then the new concentration would be, not 3, the new concentration would be divided by 10. Okay, so that's what the inverse relationship means. And for simple changes, we can just sort of think through what will happen to the concentration. But if we want to be more confident and if we want to do maybe different changes in concentration, then this equation is going to be really helpful. So this equation is C1V1 equals C2V2. So C1 refers to the initial starting concentration that you have. C2 is the concentration that you want to make. V2 is the volume that you want to have after you add the water, after you do the dilution. And so V1, in most instances, V1 is what we're going to be solving for in this equation. So the first thing I would do is I would rearrange this equation to get V1 by itself. To do that, I need to divide both sides by C1. And that turns the equation into this. So what this is going to tell me is what volume, V1, what volume of the starting solution, the higher concentration one, how much of that original solution do I need to make a new volume and a new concentration that's lower by adding water. So let me walk you through what all that means with some examples. So let's say that we're starting with a concentration of 10%, a 10% solution. So it could be a 10% salt solution by mass, or it could be a 10% alcohol solution by volume or by mass. So it's a percent solution, and we'll keep it at that. So if my starting concentration is 10, and the concentration that I want to make is 6, and I know I want to make 100 milliliters for my lab experiment. So then the question is, how much of this original 10% solution do I need? How do I actually go about making the 100 mLs of 6% solution? That's what I'm trying to make. Okay, so we can plug in our numbers, and I can plug in, I want to make a 6% solution, and I want to make 100 mLs of that, and I'm starting with a 10% solution. Okay, well 6 times 100 is 600, divided by 10 is 60. So the volume that I need is 60 mLs. Okay, so let's actually try to put that into practice. What does that actually mean when I get that number 60 mLs? So that means if I wanted to make the solution, to make 100 ml of a 6% solution, step 1 is measure the 60 mLs of the original 10% solution. And then step 2 is add water, assuming water is your solvent, add water until you get your final volume. Our final volume here we decided was 100 mLs. So add water until the total volume is 100 ml. Now, I know you'd say, well, why didn't you just say add 40 mLs of water? Well, when we make solutions, it's important that the total volume is at our desired volume. And sometimes when you mix two things together, two liquids, or it could be, well, I suppose it could be anything, but usually we're thinking about this in terms of mixing two liquids. Sometimes when you mix them, they don't actually add up to the two separate volumes. So you mix 60 and 40, but when you mix them together, they may actually only take up 95. So sometimes, depending on the liquids, they can do odd things like that. So we always go for what's the total final volume. and we make sure that we add water until we get to that total final volume. Let's do one more example just to make sure that we know what's going on here. So if I do another example over here on the side, again, let's say this time we start with a concentration that is 20%. We don't know how much of that to use. That's what we're going to try to find. But we do know that we want to make a 4% solution, and this time we decided we're going to need 250 mLs of that 4% solution. Okay, so to set up our equation again, C2V2 over C1 will equal V1. Okay, so now I plug in. I want to make 4% solution, and I want 250 mLs of it. I'm starting with a 20% solution. Now if we do that math out, 4 times 250 is 1,000 divided by 20 is 50. And you can use the calculator for that. So I solved that the V1 is 50 milliliters. So that's how much of the original solution I need. So again, what would my steps be? Step 1, measure 50 ml of the 20% solution. Step 2, add water to get 250 ml total volume. And yes, I know I'll be adding about 200 mLs, but I'm going to make sure that the final combined volume is 250. And now I'll have 250 mLs of a 4% solution. I can then divvy that out. I could measure out 5 times 50 mLs. Maybe I'm doing 5 trials at this concentration. So now I've made enough to do all 5 trials. So this is the method. That's how you would actually walk through doing it. And that's 2 examples of how to use the C1V1 equals C2V2 equation to calculate how to take a more concentrated solution and dilute it down to a desired lower concentration.